Hello, good evening. It's been a long and anxious wait for some of you. Some of you have heard or seen answers going around. I do not know if they are all correct. Some are right, some are not right, and I don't know which one you have seen. So I will not comment on whether the answers you have seen are right. And in any case, uh, I also am not going to talk about cutoffs because if your answers that you saw are wrong, then the scores that you thought you got are wrong, and the scores that you told me you thought you got are wrong, and therefore everything that I have as data is also wrong. Okay, so only after I at least have talked about enough, then I will try to make a reasonable judgment about the SMO cutoffs for this year. But my initial comment is that this is quite a normal paper. It's quite a normal paper, means that if you are too sleepy and you're actually taking open and you need to go to bed and you're like, what does the most likely cutoff score for junior uh, likely equal to? I would say whatever it was last year for all the various ones is a very possible cutoff, right? Meaning that uh, that is something I will revise at the end, but initially, a priori, that's what I would say. If you have just been in the senior section, you will realize, especially for the Sec 2/Year 2s around here, that you are very grateful you are doing junior. If you are in Sec 1, you probably don't feel very grateful yet. Some of you are like, no, this is quite hard. But hopefully, by the end of the session, apart from knowing your score, you also have learned some things. And for whoever is watching this in 2027, 1 or 2 days before the actual SMO Junior, I hope whatever last minute cramming you're doing is somehow useful, as it was useful for those of you who are watching this live and were also doing last minute cramming with the 2025, 4, 3, 2, and 1 streams. Now, we will see what the general opinion is going to be, but I will just get started with the problems without any further ado. Invite your friends if you would like to sort of have moral support, or if you would like to try to persuade your friend that you're having an argument about whose answer is correct. Ask them to join. This is not a reserved session. This is free for everyone to watch. Okay, question 1. Let m be a constant. If x plus 3 is a factor of x squared minus 2x plus m, which of the following is also a factor of x squared minus 2x plus m? Now, this is quadratics, which is one of the recurring themes of junior papers as well as this paper, right? Lots of random appearances of things that are quadratics. I will say that quadratics is one of the things that is going to be very distinguishing between the average year 1 and average year 2 student in your opinion about whether a quadratic question is easy or hard, right? So if you are year 1 and you are like, no, this is hard, don't feel bad, but 1 year later it should feel easy, right? If you are in year 2, there's a higher chance you find it easy, although technically some of it is only taught in Sec 3-ish, like discriminants, completing the square, may not actually be in Sec 2 math. So for this one, I said long division or Vieta's can work. Now, the Vieta's approach is to say that if x plus 3 is a factor, that means that negative 3 is one of the roots. Vieta's tells you that the sum of roots is 2, and so the other root must be 5. If the other root is 5, then that means the other factor is x minus 5. Now, you can use long division to just also do roughly the same thing, which is to say that there should be no remainder. So if I do long division, x squared divided by x is x, multiplied by x, and subtract. Bring it down. Negative 5x divided by x is minus 5. And so you learn two things. One is that, of course, this should be 0. And the second is that this should be the other factor. Okay, so you have at least these two different ways. I'm not going to talk about the factor theorem approach. Okay, factor theorem is something that I'm parking as more like SMO senior thing. If you know that, then you can just sub in -3 as well, and then factorize it later. All the same thing. Okay, question 2. Your not shaded quadrilateral. Did any one of your schools not mention about this shaded, not shaded quadrilateral thing? Because clearly for whatever reason the paper, like there are shaded things, right? The other geometry questions, there are shaded things. Don't know why this one not shaded. But there's only one quadrilateral, so I hope that even if your school forgot to say it, it is pretty obvious what it is referring to when it is a quadrilateral. This is a very typical AMC 10 kind of problem. In other words, American style geometry. The American style geometry is always lots of shapes, try to form one equation, often using Pythagoras, and then solve that one equation. That's often what happens. So we are going to do exactly that. 5 circles. Make sure you read the question carefully because the information sometimes can be important. But then in this case here, I would say that there isn't really too much important things except for the fact it's diameter, not radius. Diameter of the largest circle is the whole thing, right? The whole thing here is the largest circle. That is x. So first I can just cut it across. It's symmetric. And so I know that this would be x over 4. Then I want to form my equation. I also want to get my area. And both of those things are going to make me want to draw this across because it's a rhombus. So if I want area, I draw that because I want to use the area of the rhombus is the two diagonals multiplied divided by 2. If I wanted to use Pythagoras, I get a right angle, so I'm also happy. So I can do that. Now the issue is, okay, but what is this length down here? And the answer is that we don't know yet because we do not know the size of the top and bottom circles. So because we don't know the top and bottom, we just call that radius r. This would therefore be also r. This would also be x over 4. And this would be x over 2 minus r. So this already makes sense that it should work because I just need to find r in terms of x, and then I can find the area in terms of x. To do that, we will just use Pythagoras on that right angled triangle. This is one of the differences between, let's say, your primary school style Olympiads and the SMO Junior. It's that there's always going to be a chance that your geometry questions, your counting questions, your number theory questions incorporate some algebra inside. That doesn't mean that they are easy or hard if they have algebra. It depends on what kind of algebra. But don't be afraid to form an equation. Don't assume that you can just find every length one by one in a so-called non-algebra fashion. Okay, so I'll expand this. Stuff cancels. You can cancel an x. And so you get x over 4 equals to 3r over 2. And so r equals to x over 6. That means that this length here is x over 2 minus x over 6 is x over 3. And then your area times 4. So area of the whole rhombus is x squared over 6. Now, this is definitely not the second easiest question of the paper. It is not guaranteed that the questions are in order of difficulty, as I'm sure you will know retrospectively if you just did the paper today. Right? So it's not always in order of difficulty. That means that really just if you're watching this for next year, for 2027, do jump around. If you are hoping to finish most of the paper, jump around just so that you do questions you feel like doing first. That's okay. If you're hoping to just, let's say, do something around like 1/3 to 2/3 of the questions, which is a very common kind of target range, then all the more you can jump around because the questions may not be always the type that you like in the front. Okay, number 3 is absolute value. Now, absolute value sort of and the floor function have showed up a little bit more in the SMO this couple of years. The absolute value, which is this vertical lines, it's not a very complicated thing, right? Just like the floor function round down, it's not a very complicated thing. The absolute value is just saying that sort of like remove the negative sign, if any, which also can be written as if x is, let's say, positive, the absolute value of 5 is itself, the absolute value of -3 is 3, right? So that's all it means. So that means that maybe x is positive, right? Maybe x is positive, and if x is positive, then the absolute value does nothing. X minus y is 4. Oh, so answer is 4. Can we say that? I'm sure somebody said that. Maybe many of you just like don't know what the absolute value sign means is okay, right? Then forgive it. But if let's say you're like, I just assume it's positive, know that what the second equation is also there, right? You also need to check that. So if x is positive, these are the two equations. Now, the second equation is very factorizable. You know x is non-zero. So if x is non-zero, you can cancel it off. And so you end up with y equals to x squared. If y equals to x squared, you can put it in x minus x squared equals to 4. And the question is, can you solve this quadratic? The answer to the question is no, you cannot solve this quadratic because of the discriminant, the b squared minus 4ac, which in this case this is negative, right? So therefore, nope, doesn't work. Therefore, I need to do the negative case where x is less than 0. Actually, the x is less than 0 will not really be that different, just that you won't get the answer immediately. And you get all these weird square root options, so you know that a quadratic is eventually coming. Now, if x is less than 0, what the absolute value does is remove the negative sign, but it removes the negative sign by negating it, right? Because how do you remove a negative sign from a negative number? Is you take negative of the negative, it becomes positive. So that's what actually the absolute value does. Okay, now almost the same thing happens. You factor out negative y. And so again, x is not 0. So you end up with y is negative x squared. You put it into there and substitute it. You get negative x plus x squared equals to 4, which is almost the same thing, except very importantly, the signs are now swapped around. So we just solve the quadratic equation. This one is actually solvable. Just use your quadratic formula. I think I mentioned all of this in my video, right? For all the junior formulas, I said that we may need this. So very early on, it turned out to be useful. So the same b squared minus 4ac actually, I said that now it's minus 1 squared minus 4 times 1 times minus 4, 2. So 1 plus minus root 17 over 2. Which this is the x is less than 0 case. So that means that you take the negative one as your value of x. We know that in this case, y is negative x minus 4 or y is negative x squared. I'm sure we know which one we prefer to use. So we just flip it around. That's negative x minus 4. And then we just calculate x minus y. Now this is not an easy question, but it is not like a question that requires you to be very creative. You just need to know all of these like fixed procedures. And these fixed procedures are going to be things that you will need to know in school soon, just not yet. So it is good to know them anyway. Okay, so it will simplify to your final answer, which is e 5 minus root 17. Question 4. This is also pretty classic from the past SMO junior questions. In some years that I forget, this like comparing a pair of square roots. The idea is simply that I mean this 20 is square root 100 plus square root 100. That's what it really is. And so you're trying to see whether you can compare these three things which are quite similar to each other. Just that from 100, 100, you went to 101, 99, 102, 98. Now, a very typical way that you can sort of guess an answer for SMO comparisons is to say that, okay, if I continue the pattern, right, I probably am going to get bigger and bigger or smaller and smaller. So let me just continue all the way to 200 and 0. It's pretty obvious that this is going to be less than 20, right? So therefore, it's probably that if I move in that direction, it's getting smaller and smaller, and C is the biggest, B is the next biggest, A is smaller, and that would be correct. So just small little trick to be aware of, but that's certainly not the entirely intended solution. Although some of you who know that behind this is that this can be the justification because it's an instance of Jensen's inequality, which is all over SMO senior. The simpler way to do is just square all of that. because the thing is that you want to be able to compare them. I can even purposely just square the 20 in this way just for effect. Just to highlight that, okay, look, all of these guys on the left, all the same. All of these guys inside the square root, we know that they have the same sum, and therefore we know that this is going to be decreasing because they have the same sum, but they are getting further apart. So this will confirm indeed that your CBA is in that order. Okay, last one is the multiple choice. Number 5 is something that I was trying to convey a lot using my hard SMO, which is if you see something appear more than once in an equation, just substitute it, call it whatever your favorite letter of the alphabet is. You can call it a Greek letter, you can call it Jia Yi Ping Ting, or you can call it whatever you want, just substitute it when you see it more than once. Now, in order to recognize that, you have to sort of be able to mentally know that x plus 6 squared is x squared plus 12x plus 36, and this is x squared plus 12x plus 37. Therefore, you can take your pick. Do you want to substitute in y is x squared plus 12x plus 36 or x squared plus 12x plus 37? In fact, technically, you can pick neither, right? Because the 7, you can just cancel it off first. And so maybe I will just pick x squared plus 12x plus 37. I'll just pick x squared plus 12x plus 29 sounds a bit better. Actually, all of this doesn't matter. Just do any one that you like. The point is that when you do a substitution, you're trying to just make everything look a bit better. So that certainly looks better. I can square it to get rid of the square root. Don't forget that when you square, you also square the 2. And then we get a quadratic. Someone can keep count how many quadratics there are in this paper. We get another quadratic, which we can factorize. We know that minus 4 doesn't work because it is a square root, and the square root cannot be negative. So it'll be y equals to 8. We put it in. You get another quadratic. But this one, because you're asked for the product of the 2 real roots at the end, you can just use Vietas to say the answer is 21. Right, so 21, which is 8. Okay, so MCQ. Okay, not okay? I think it is probably somewhere in between. The question 3 is pretty annoying in terms of like having a bit more work to do. But then I think conceptually maybe question 2 is the one that is a bit more difficult. Overall though, still considered as pretty normal junior so far. Yeah, sorry. So the thing is that I do not always seem to be responding to the chat because like I said, I put a bit of like a 30-second latency just so that among other things, if my internet cuts out, the stream will survive. And also that my computer does not lag to death. It also means that every time I'm like, the question is okay, let's move on. And then after that, you're like, no, the question was not okay. But I've already moved on. So It's a live stream. It is recorded. If you are trying to get answers, I go through answers. But if you miss anything, you can always replay it back. If you're watching this a year from now, that is also still true. Okay, so I think we will continue. We will continue up to question 10. And the next few questions are what can broadly be described as like your primary school like questions, right? The next three problems. It is entirely possible, in fact, that the person who is setting these few problems may well be the same persons as those who are setting your NMOS and your SMOPS, your RMOs, because all your primary school contests proposed by your RI teachers and US High teachers, Hwa Chong teachers, ACS teachers, whoever it may be, they also can propose questions to the SMO. The SMO can choose whether to accept it, to accept one of them, to change it, to not use it. But if it just feels like, hey, I've seen this before, maybe it really is because the same person proposed the question again. So the good thing about SMO is, well, two good things. One is you have more time. I heard someone complaining that there's not enough time. I think it is, if it is not enough time for SMO, it's almost a good sign because it means you're doing quite a lot of questions. But otherwise, you have enough time. And secondly, you know enough algebra that if you are like, I don't like this kind of questions, I hate drawing models, you don't have to draw models, right? You can just use algebra. So this question here, we shall just draw it. A is going here, B is going here. 5 hours later, they pass each other. Another 3 hours later, reached village Y, but car B was still 90 km away from village X. Okay, so actually I don't really need algebra for this. Clearly car A is faster, so I will just draw it as A covered more distance. Then B. And then A is 3 more hours. B did 3 hours. And then there was a last 90 kilometers here. We can see that these two are equal. And so therefore we know that the ratio of their speeds is 5:3. Therefore, I can do the very primary school like thing of just calling this speeds 5 units and 3 units. 3 times 3 is 9, 5 times 5, 25. And then you will have, this is 16. And the total is 40. Units is 225 km. Question 7. Again, kind of like borderline primary school style questions, but the difference is that now I'm just going to just do algebra without thinking. So you've got 4 numbers, and then they spend a very long time explaining exactly what they're doing. They first tell you what they're going to do, and then they in other words, and then they explain it again. It's literally in other words. There's too many words here, but it is a very simple process, which is that these are A plus the average of the other 3, B plus the average of the other 3. Maybe I'll write it in order, right? I'll just put the A, B, C, D in the same order. Then you have C and the average of the other 3. And then you have D plus the average of the other 3. Good, so I just add them all together and I will be done immediately. Right, I'll get 2 of each because it's 1 and 3 1/3. I have this sum. What's the last number? Last number was 57. And then you want the average. I'm sure that somebody that did this and accidentally wrote down A plus B plus C plus D is 84 as your final answer. Now, these are the kinds of things that do happen. Please do like recognize what sort of mistakes you tend to make. Like, means are you the sort that read question wrongly, calculate wrongly, forget negatives, off by 1, or like just don't know how to do addition without a calculator. These things do happen. Okay. So of course you are supposed to take the average, which is 21. Okay, question 8. 1, 2, 2, 1, and m. Find the value of m such that it's possible to fill in the remaining 6 empty cells with 6 distinct positive integers different from 1, 2, 2, 1, and m such that the sums of the positive integers in every row, every column, and every diagonal are the same. Okay, so here is the interesting thing, right? The interesting thing is that, oh, so actually this is enough for me to find m just using those two numbers. And we can't really use a magic square. So it is like a primary school style question, but the easiest way that we can probably do this is to just use the basic fact that we know that the middle number will be the average. So if I call this number x, the sum is going to be 3x. This can be done in a lot of ways. You can justify it. It's a basic property of a 3 by 3 magic square. So if I call that x and the sum is 3x, then I can just fill in the magic square like I'm filling a magic square. Like, oh, sum is 3x, this is x. So this is 2x minus 2 to 1. And then after that, this one is 2x minus 1. This one here would be x plus 2 to 1 minus m. This. Now, the point is that at the end of it, we should get some equation that was not known. So if you were to reach here, you realize that, okay, actually these two things are not in agreement. So never mind. I'm just going to use the diagonals first to fill in those other two things. Okay, so what I've done is I have used the last two diagonals to fill those two things. And in so doing, I can see that there are some equations that are actually not yet guaranteed to be correct. The equations that are not yet guaranteed to be correct, in particular, would be this one and this one, and they both tell you the same thing. Which is that m is equal to 1, 1, 1. Now, incidentally, this is just like your normal classic magic square. You can see that the corner one would actually be the average of those two on the other side. There will be some sort of addition and subtraction way of deducing it. But I am sort of explaining the more like just, it is bound to work if we do enough algebra method, which is probably the mindset you're more in for the SMO Junior. Okay. Question 9 is not P6 like. It is just one of those things that is like a super easy senior question. So super easy senior question when it brings to junior, is that super easy? Maybe, but I'm sure that there's some of you who just try x equals to 1, 2, 3, 4, 5. And then after you try 1, 2, 3, 4, 5, you realize that x equals to 2 works. So seemingly you guessed it and you are right. Well, if you did that, you are right. Now, let me explain how this can be done firstly in the more like junior way, which is just by calculating the different cases. And then I'll explain the more intuitive way, which is also something that I massively upgraded for my hard SMO senior open paper. I forgot which one. Okay, so firstly, the boring way. Now, the boring way is to say that these absolute values, as noted earlier, they will either do nothing or flip the sign, depending on whether inside is plus or minus. If it's 0, of course, that's same as doing nothing. And so we know that they will change sign at -1, that's when this is 0, at 2, this is 0, and 4, that's when this is 0. Now that means that if there are these 3 different places where it changes, there are 4 zones, you can just check all 4 zones. Boring, but it does work. Okay, so if x is in the bigger zone, everything is positive. So in this zone, you can think of it as like the World Cup is starting soon, right? So it's like the World Cup qualifiers is that the top few countries in Asia get in, the top few countries from Europe get in, from South America and so on. So, and then from each country, the best players are selected. So it just means that in each zone, you're like, okay, for this zone, why is 3x minus 5? Now in this zone, how do I make it small? The minimum is when x equals to 4, and it is going to give you 7. So, okay, that is the best candidate from the 4 or more zone. And then after that, I can go with the 2 to 4 zone. In the 2 to 4 zone, x plus 1, nothing happens. X minus 2, nothing happens. X minus 4 is now negative, so it flips around to be minus x minus 4. Sorry, 3, not 5. Now this time, in this zone, the smallest is when x is 2. It gives you 5, so that's better. And then we just repeat this 2 more times. So again, I'm saying for SMO Junior, you are not in a huge rush unless you're aiming to solve like 23 to 25 questions. If you are aiming for that, I'm sure you know well enough most of this that there are plenty of questions you can solve almost instantly. So still, you are usually not in a huge rush. So you can afford to do this if we can't think of anything better. Have patience, I will show the a bit better in a little while. Okay, so this one, the minimum is actually going to be also the same as x goes to 2. Because when x is -1, this is actually 8, right? So you want x to be as big as possible. So your minimum is going to be, well, x cannot be 2 here, but I can kind of just glue them together, it's fine. So it's still going to be 2 again. And then for the final zone, when x is less than or equal to -1, everything is negative. The minimum is when x equals to -1, which would give you 8. So this is the rather boring but reliable way that you can do some of these kinds of questions. Whether they ask you to find the minimum value, find the value of x such that this is equal to 10, 20, 14, or find how many values, you can always do this approach. However, there is a more efficient method, which is that if you understand how the graph works. If you understand how graphs work, you don't need to actually draw out the graph precisely. The whole idea is just that it is made up of some straight line graphs, linear graphs. I know that for some of you, this may be the last topic you just did in school or the next topic you'll do once school reopens. So linear graphs, you don't need to know anything about that except that linear graphs, you just glue a few of them together, whatever the shape is, I don't know. If it's a bunch of straight lines, I only need to check all of these places. Now you notice that in what we just did, ended up we only checked 4, 2, and -1. So actually when you realize it, hey, I just check -1, 2, and 4 here, I can just check this straight away. So that is true. Actually, you only need to check these. That is enough. Someone's going to tell me that I need to check as x goes to infinity. For that one person who's thinking of calculus, good for you, but the answer for a SMO question is not infinite. Okay, number 10, before we take our first break. This is very messy looking. It is often the case that for some of these sorts of things, they are actually like worse because you substituted the value in. Meaning to say that sometimes you're like, oh, you mean that you rather actually do algebra? Yes, because doing things with surds is still doing algebra, except more ugly. So I'm just going to call this x. And this is the reciprocal, which is 1 over x. And then what you need would be x4 plus 1 over x4. If you've done any SMO problems before, SMO Junior, almost all the time you will see something like this that is like, oh, it would be useful to start from x plus 1 over x. Which is something that is far more reasonable to compute because I can just, I mean, those are conjugates. So if I add these two, it will not be that ugly. Okay, so you end up with root 5 plus 1 squared, root 5 minus 1 squared. At the top, the bottom, root 5 minus 1, root 5 plus 1. When you have conjugates, they always go pretty well. The bottom is just 5 minus 1 is 4. The top, the square roots will also cancel out because you have 5 plus 2 root 5 plus 1. 5 minus 2 root 5 plus 1. These are gone. And so you realize that, oh, it's 3. That's not the answer, but the fact that that is 3 means that you can then just go for the approach we normally use, which is square and square again. Yeah, so square again. Okay, so that's up to question 10. We will take our first intermission here. You can take the next few minutes to go and grab a drink, get a snack, or spend all of the time complaining in the chat about various things that happen in the SMO. If anyone is taking open tomorrow and you want to go to sleep and rest, feel free to do so also. The thing will be remaining up forever as long as you want to see it is there. But otherwise, we will be back in about 5 minutes. We will do the next probably 8 questions or so in our second section. Okay, so not that many complaints actually. So I think maybe I was used to the senior one just now. If any of you are taking senior next year, you can and you didn't already, you can watch the replay of the senior one, and you will be very stressed by the questions, and then you can look at the chat to distress a little bit. Otherwise, question 11. This is actually quite hard as a problem to do without trigonometry. I'm always on the fence about trigonometry, meaning that as of SMO junior team, SIMO junior team, there's like sort of like no questions require the use of trigonometry, no questions require the use of coordinate geometry. Everyone is doing trigonometry and coordinate geometry. So for SMO junior round one, the same is true, but you are most welcome to do one or both of those things. So I guess I can show the trigonometry approach first. Right? Then after that, I will sort of say that, well, where did the cosine rule come from? And therefore, how could you have achieved the same without actually technically saying I am using the cosine rule? Okay, so this is a 5, 12, 13 triangle. Actually, I should refresh my Microsoft Word first to prevent any lag. So let me just do that. It's a 5, 12, 13 triangle. So it's a right angle triangle. That is not 100% going to be like necessary to solve a question, but like it has to be the right angle triangle in order for it to be reasonable to do without trigonometry. Now, I will still give the trigo approach first, which is simply that when you are told that DE divides the triangle ABC into two regions with equal area, if I call these X and Y, the equal area basically tells you that X over 13 times Y over 12 is 1/2. Right? That's your ratio of areas, which means that XY is equal to 78. You then have got, this is M, at the minimum case, your cosine rule, and cosine A is 12 over 13. Now, by, you can say AMGM, x squared plus y squared is greater than or equals to 2xy. Which is then going to be equal to 12. So this would be the so-called slightly more high-powered approach of doing it. That is pretty fast. I will leave you to think for those geom people, or like what is the simplest way that we can actually prove M is minimized when X equals to Y without, let's say, doing this algebra. However, if we were to just avoid using the cosine rule, here's the sort of like cheating way of accomplishing the same thing. You know that you want to get the area. So if you don't use this, then the alternative is half times base times height. So now I'll erase this and write down the alternative. This is all recorded. I realize I don't have to worry about deleting my workings. The point is that this is a 5, 12, 13 triangle, which is right angled. If you draw the height here, you do know that it is going to be similar triangles, ADF and ABC. Which means that when you scale it down, I can call this smaller one 5x, 12x, and 13x. So that would be followed by saying that that means if this is half the area, this has to be half of the triangle's area. And that would give you that it is 6 over x. Is this part minus 12x. Now this is m, so you can use Pythagoras to say that m squared is equal to 5x squared plus 6 over x minus 12x squared. Expand this. Two times this is minus 144. And then you can basically do a quasi-completing the square by matching these two terms. And it will tell you, therefore, that the minimum again is 12. Also telling you that when 13x equals to 6 over x, which is the same statement just now as AD equals to AE. Like doing SMO junior geometry strictly without trig is almost like akin to like doing primary school Olympiad questions without algebra. You can, but you are sometimes just taking a weird circuitous route that is honestly a lot harder. So given 1 year of time, maybe you prefer to learn some trigonometry. If you have 2 days of time, like you are watching this 2 days before Junior 2027, then probably just do what I just did, is your best chance. Okay, question 12. This is also back to quite standard. When you see something like this, we know that these square root kind of expressions only really simplify when you multiply with their conjugate. So I don't want to expand this whole thing. I will substitute them in though, just to check, right? So if I put in this plus 3, plus 4, plus 10, plus 11. Oh, great. So I can immediately pair this up and good thing should happen. Now be careful with the negatives here. There are some issues that can happen. If you got a negative answer, you know you're wrong. Right, so this and this, you'll get root 5 squared minus 4 squared. Root 5 squared minus 3 squared, which technically both are negative. And so they multiply to 44. This one, pretty short actually, and pretty typical of SMO style questions. No issues, right? The stream is up. Let me check. Don't see any issues on my end. Yeah, looks fine. Okay. Okay, 13. You have angle bisector BF of ABC and DF of ADC. You have got angle A is 36 degrees. And you've got angle C is 58 degrees. And you're asked, what is this? As noted, this is very much in the style of some kind of primary school style problem again. There isn't really a need to try to do something very heavily geometric with angle bisectors, or for that matter, anything geometric, we start by saying, can I just treat this as algebra? Because do I have enough pieces of information? If there is, then I don't need to look any further. I did put up a video on angles some time ago that you can use some fancy directed angle stuff to sort of instantly form one equation, but a more practical way is just to say, let's call these angles here alpha and alpha, beta and beta, and see what I can form. Although technically speaking, if I form this alpha and alpha, I don't really have this to be beta and beta anymore, because this would be 2 alpha plus 58 degrees by exterior angles. This would be 2 alpha plus 22 degrees, subtracting off. And then both of these will be alpha plus 11 degrees. So those are not independent. Now, the thing is that I am quite certain I can draw this thing for any alpha. So there should be enough information here. And indeed, a very simple way that I can finish this off is to just use this arrowhead concave quadrilateral. This was x. 2 alpha plus 58 equals to alpha plus 11 plus x, which gives you x equals to 47. But plenty of other options exist. You can use angle sums of like a whole bunch of different triangles and finish it off on there too. For anyone that has forgotten your angle properties, when you have this reflex angle one, it is like this just because this is 360 degrees and the angle sum in your quadrilateral is also 360 degrees. So this one is equal to the sum of the other three, just as this is the sum of those two. If you see the question and like, teacher, you said every time the questions you get stuck is because you don't find similar triangles and don't form an equation. Well, you form those because you get stuck, right? So which means you do something straightforward first. If it doesn't seem enough, then probably there is some additional geometric property that is somewhere. Isosceles triangle somewhere, parallel line somewhere, perpendicular line somewhere, etc. Right? But if you can form it just like that, then no need. Okay. 14 is hard if you've never seen the idea before, but the most recent junior question, if you were grinding old junior papers, the most recent junior question that had this associated idea was junior 2019 Q20. There are others in senior, open, AMCs, and other contests, but for junior, this is the most recent one. And the idea is simply that you will take these geometrically. You are going to look at this and say, I have no idea how to guess x and y. I cannot square root these things. I have no idea how I would use any inequalities. I may or may not know whether it be AMGM, it could be Cauchy-Schwarz. Doesn't work. But we can complete the square of the x and the y's. Now, of course, when we say complete the square, it means that you use the x's, and then after that, oh, I borrowed 1. Then after that, I used the y's, I borrowed 4, and then I realized that the 5 exactly fits into them. It is possible there will be a leftover, in which case the question will simply be very hard. But in this case, it is good. So the next thing that we can then deduce is that with x minus 1 squared and y minus 2 squared, x plus 2 and y plus 2, this reminds me of Pythagoras. But before I draw the Pythagoras, I want to note that to make this small, to make it small, I should actually make it such that my x minus 1 and y minus 2. There is no reason for my x to be more than 1 or for my y to be more than 2, because beyond 1 and 2, I'm just making both of them bigger at the same time. There's no good reason why you would pick that for the minimum. Instead, you would rather flip them around. And we know that for squares, we can. So that now I'm actually dealing with positive squares. I can also say that there is no reason why x and y should be less than -2, but I think that is more obvious, so I don't need to write that down. Now I can do the Pythagoras logic, which is to draw these triangles. And the clever part is that, let's say I don't know what x and y are. Never mind, I'll just put these two triangles together. Okay, this is probably not the correct scale for my x plus 2 and y plus 2. What you want is going to be the total of this length and this length. That is going to be minimized if you can make it a straight line by the triangle inequality. Because we know that this and this just form a 3, 4, 5 triangle. So I just will need to pick my x and y such that this point lands on the line. Certainly possible. I don't need to worry about how exactly to pick x and y, although similar triangles would answer that. So I'll leave you to find out what x and y are with similar triangles. But otherwise, the answer is just going to be 5. It's the maximum when this point is chosen to be on the line. If you want to be slightly fancy, you can express this using quad geom and describe this as like the coordinates of A, B, and C are blah, blah, blah. If you want to be very fancy, you can say Minkowski's inequality. But a normal junior solution would look like this. Okay, question 15. The actual problem did not mention that A is not 0. It doesn't explicitly say it. So unfortunately for some of you, that means that you included the case with a 0. The understanding is that 3-digit numbers means that the first digit is non-zero. Okay, so that is understood whether or not it is explicitly mentioned. So sum all the 3-digit numbers ABC for which this 6-digit number 1, 2, 3 ABC is divisible by all the 4 numbers 2, 3, 5, and 7. 2, 3, 5, and 7 are just your 4 prime numbers. Divisible by all just means you can take the LCM. $210. You do not need to use divisibility tests because it is possible. You can say that, oh, based on this, like last digit is 0, but honestly, you just take 1, 2, 3,000 divided by 21, sorry, 210, or 1, 2, 3, 0, divided by 21, and that's probably going to be faster. Okay, so just divide. You will get 585. Remainder. Now, the remainder is actually more important. Remainder is 150. I'm not showing any of you long division, right? It is too boring for me to do long division for you of numbers. But if you personally feel that you always make careless mistakes with computation, after you've done the computation, just double check it in whatever way you need to double check it. Okay, so the remainder is 150, which means that for you to reach the next multiple of 210, you need 60. And so, of course, another way of saying this is that your ABC is congruent to 60 mod 210. But basically your values, if you ignore 60 because it's not a 3-digit number, these are the 3-digit numbers. You can say I pair them up to add them, or they're just 4 numbers. I'm just going to add them however I want. Up to you. The sum is 2340. Now, question 16. I think this is one of the culprits, right? Uh, yeah, some of you who told me you scored N. And then after that, like about 10 minutes later, while I was still busy doing senior problems, you're like, oh, sorry, I got N-1 because of like question 16. At that point, I hadn't read question 16. I was too busy preparing senior. But then now I look at it, I'm like, oh yeah, I can see why that happens. The surface of the question is integer pairs, not positive integer pairs. So that is, yeah, one of the culprits. Otherwise, it is quite a simple start because this is very factorizable. I think some of you probably have a whole lot of factorization exercises from school, right? If you haven't gotten it, you'll get it soon. I remember one day when I was in US High as a student, I was taking the accelerated class, and then after that I came back to my class after that, and they were all very sad because the teacher was so fed up that basically gave them 100 factorizations of quadratics and told them that they couldn't leave before doing it. So I don't know if that still happens to you. This certainly should not be the kind of quadratic that is hard to factorize. It is also, then you're basically done because you know that you can just assign any two factors. This is not one of those cases that, oh, but x and y, would they be an integer? No issue, because if this were, let's say, a and this were b, then the y would just be the difference, and the x will then be this. So as long as your a and b are integers, you are fine. So you just go and factorize this. Factorization of 2026, right? I say it's important. 2 times 1013. If you want to know 2027 is prime, it is prime. 1013 is prime. This means 4 factors. You can put them in either order, but you can also choose the plus or minus. And hence it is 4 times 2 equals to 8. You can actually afford to list all of them, but it's really boring, right? It's just that you will just have like, okay, if this is 1 and this is 2026, I sub in here, and it's like, okay, so therefore y is 2025, and then x is negative 2024 or something. It's pretty boring. So you can check, but it is, this argument ensures that we know every pair works. We don't have to actually write them down one at a time. 17. The main complaint about this is that it's geometry. It's not that bad. Apologies for a lousy scan diagram. This is the best that I could get from the copies that I received from all of you. So I am using this. Find the total area of the unshaded regions of the two rectangles. And speaking of which, the question, someone definitely found the shaded area. Someone definitely didn't read congruent. For geometry questions, please read the problem. Otherwise, you'll be like ChatGPT. When I put this into ChatGPT, basically it couldn't solve the question because it looked at my admittedly not very good photo of the diagram, and it just somehow thought that D was the point and it was on FG, and then it couldn't solve the question. So if you're just using the diagram, you will miss important information. Okay, so how do I do this? Let's put down what we know first. So this is 8. By the fact that they are congruent rectangles, it means that the shorter sides are all 8. I should put that down before I forget. HD is 4. So this is also 4. HF is 2. and that is all I know for now. Otherwise, if I call the other side length x, right, it's always x. This is x minus 2. Okay, so what do I do? Honestly, there is more than one way to do it, but the fastest is almost certainly just to use the right angles here, and then equation again, right? Pair of Pythagoras to find what x is. Bit of expansion again. Is anyone still keeping count of quadratics? So you will get x equals to 13. Now after that, you know that you want the unshaded area, right? The total area of the unshaded region. So what you should be doing is that you take the area of two rectangles, which is the same, of course, both rectangles, minus the shaded area, right? No, that's not right. It's two rectangles minus the shaded area times 2. Again, something that I think happened to a few of you. Because if you just took away the shaded area, then you're just finding the area of the whole diagram, right? You don't want the shaded part. And unlike question 2, they actually did shade the part, so you have no excuse to say that your paper is not printed correctly. Okay, so area of rectangle is 13 by 8. The area of these two triangles, half times 4 times 13, half times 8 times 11, and then times 2 again. You compute, and you are left with 68 as the total unshaded area. Okay, one more, then we will take our break. ChatGPT, I'm just testing it actually. I'm testing capabilities. I will say that, let's say for example, when you are using ChatGPT to solve these questions, it is not fully reliable, but it gets it correct now maybe 75%, 80% of the time. So that's not bad. I'm just curious, right? Last year the rate was a lot worse than that. In terms of setting questions, however, it cannot do that. You go and try to ask ChatGPT to set a mock paper, it can't do that for you. Otherwise, my life will be a lot easier and the SMO will not have so many mistakes in their questions. Okay, so question 18 is an equation. Find the value of ceiling. Sorry again, this is much more like overpopulating the senior paper, but it seems that nowadays they're trying to test your eyesight. So ceiling means round up, right? Smallest integer greater than or equal to. This is your ceiling bracket, right? The floor bracket is the round down. This is the ceiling bracket. It's actually one of the math notations that makes sense. So you have the ceiling of b over a. The ceiling is not important. The main thing is just, can you solve this equation? And so what I will do is that I am going to just let x be b over a. I know you see the x here, this is just a definition. It's just, do you not know what's a ceiling? Then here it is, so the x doesn't matter. Let x be b over a, and then I'm going to try to make this equation look like it contains mostly b over a. Now, in order to do that, I am going to just multiply the equation by b. Okay. So now I've got this b over a on the left side here. That's good. But then on the right side, I still have this thing which is not quite b over a. Okay, so then what I can do is divide the top and bottom by a. And there we go, we get our equation. So I'll just multiply over, and we get another quadratic. Who's keeping count, right? The question does say that your a and b are positive, so we know which root to select. Pick the positive one. X is -1 plus root 5 over 2. But then again, do we need to estimate square root 5 very well? No need, because it's ceiling of x. Square root 5 is 2 point something, which means that x is 1 point something over 2, which means that 0 point something, and therefore ceiling of x is just 1. Yeah, of course, your root 5 plus 1 over 2 is the golden ratio, your 1.618, and then the root 5 minus 1 over 2 is just that minus 1. So if you recognize the number, then great. But the estimation you need is just to know that it is 0 point something. Okay, so that's up to question 18. We will take our second break here, and then we will come back and finish off the last 7 questions. When we return, you are welcome to now sound more optimistic, more pessimistic, or whatever you feel like saying in the chat. Just be respectful, please, because the truth is that for junior, the experience level matters a lot, right? So what you find easy is not easy to everyone. Just do show some empathy, because especially if you're in junior now, you do not want people in open doing the same to you tomorrow. Okay, while many of you are still here, I guess so far there hasn't really been anything that would make me change what I feel about the cutoffs, which is to say that the cutoff being somewhere similar to last year would make a lot of sense. Now, honestly, I'm not 100% sure of the cutoffs from last year. Anyway, it doesn't matter. I'm saying it's around there, right? But it means that if we're talking about your cutoffs for your round two senior bronze and HM, now the thing is that for many of these problems here, uh, unlike senior, there are, let's say, not as many like weird ways that things can go wrong, right? Means that yes, you make careless mistakes, but not to that, not so many computations, not so much weird stuff. So I will stick to the same estimate as last year. I think last year was 16-ish. I will stick to that. I think there is space for it to drop off a little bit more from 16 to something like it has space to drop off. That's my thinking. It doesn't have to be 2 points because there will be quite a wide spread of scores. Okay, so this is what I'm thinking. It is impossible to say for sure. And right now, some of you are going to disagree with me, although maybe not as angrily as for senior. So, anyways, the point is that predictions for cutoffs are kind of meaningless because it isn't a fixed percentage, it isn't a fixed number of people. It literally is just what the SMS thinks is a good idea to do, right? So it's almost like if let's say that I'll ask you to predict what is the next sentence I'm going to say. Do more geometry. Say the sentence you predicted. Let's continue. Question 19. If x is a positive real number, find the minimum value of 4x plus 9 over x. This is trivial by AMGM. And when I say trivial, I mean literally by AMGM. If you know AMGM, it is trivial because this is literally one step. And equality can clearly hold. For those of you who are preparing for round two for the first time, AMGM is a very frequently seen thing for the algebra / inequality problems, even though not in the last 2 years. Right? It is a frequently seen thing. So it would be useful to understand the intuition. And the quick intuition, I explained more in some other video on my channel. The quick intuition is just simply that these two have a fixed product of 36, and we know that when things have a fixed product and of course positive, then the minimum sum is when they're equal. This is actually also something you know since primary school. The key thing is to know that they are equal means the things with the fixed product are equal. So you would set 4x to be equal to 9 over x, and that will give you x equals to 3 over 2, and that will also give you your value of 12 as well. Onward we go. Question 20. For any real number x, define fx to be the minimum of 4x plus 1, x plus 2, and 5 minus 2x. Find the maximum value of fx. Now, if this sounds confusing, the simple explanation is that you want the smallest one to be not so small. That's all. You want the smallest one to be not so small. But of course, you know that as x gets bigger, this one gets small. As x gets smaller, this one gets big. So a very common sense way of doing is that to say that, okay, they give the example when f2 is 1. So common sense is that, okay, if let's say that my x is more than 2, then this will be even smaller. Right, so it's not going to be better. If my x is negative, then of course your 4x plus 1 is going to be the small one. So you're looking for something between 0 and 2, and from 0 to 2, these are the ranges that they're going, right? 4x plus 1 goes from 1 to 9. X plus 2 goes from 2 to 4. And 5 minus 2x goes from 5 to 1. So you know that you would like to pick the one where all of them are going to be not too small. So I can sort of take the midpoint when x is equal to 1. And quite immediately, this will confirm that the answer is 3. Because if x is less than 1, then this thing will be less than 3. If x is more than 1, this thing will be less than 3. Right? So it would give me that the maximum fx equals to 3. This is common sense, meaning that it's an ad hoc way, means also that, of course, this is not always going to work if I gave you a long list of things, right? Here there's 3. What if I give you like 7? Then this is not going to work. But it is small enough that it works, and this is one of the hallmarks of Junior. SMO Junior is one of those cases where you can use lousy methods that are not going to work in general, but there is no shame in lousy methods for round 1. Just try a bunch of values and guess. I definitely did a lot as a student, but in my defense, I had 35 questions to deal with. Now, the intended way, I believe, for this question, and the intended way in general, is to sketch the graphs. So x plus 2, 4x plus 1. Okay, so I'll put the intercepts 1, 2, and 5. It doesn't really need to be perfectly drawn to scale, right? So the one that goes through 2 has gradient 1. The one that goes through 1 has gradient 4, so it's pretty sharply going up. And then the one with gradient -2 is going down like this. So basically, this is going to be that you want to find the highest possible lowest thing, which is this. One of my students is doing a project on the Pareto frontier, and this is basically that Pareto frontier. It would correspond to this point down here, and then you can solve for the intersection of 5 minus 2x equals to x plus 2, giving you the x equals to 1 and the fx equals to 3 as well. So that is, I think, what the intended solution is, but trying values works as well. #21 is a very standard question that I remembered. Actually, I literally gave this same question many years ago, not with 1012, of course. I don't know what number I used, but I gave this question when I was giving tuition to a primary school kid when I was in Sec 1 or Sec 2. So that is literally how long ago this question has been floating around. It is a good example, however, of a problem because it is one that you can either say, I've seen it before, or I haven't seen it before, but I can find the pattern. Because what's the pattern? Just add and see what the pattern is. Okay, enough, and then you just add up and you're like, okay, so this adds up to 5, 23, 119, and then you realize that, oh, this is just factorial minus 1, the next factorial minus 1. So that is sometimes the sort of pattern spotting that you can do. If you want to have an explanation, the explanation is also not going to take very long, because for each of these terms that look like that, n factorial times n is n factorial times n plus 1 minus 1. N factorial times n plus 1 is n plus 1 factorial. N factorial is subtracted off, and so therefore, actually your sum is this, this, and so on. Before you think that, do I need to use the Chinese remainder theorem? You certainly do not, because this is very, very divisible by 2026. So it's just -1, which is then 2025 mod 2026. Again, I'm sure that there's someone that by accident thought that 1013 factorial is 1013 mod 2026. Sorry if that happened, but it most certainly is not. Okay, question 22. We are making good progress. Angle ABC is 60 degrees. You have midpoint, you have 4, and then your CA equals to 2 times of CM. AC equals to square root K, find the value of K. So don't worry about K, it just means find AC. And it will expect it to look like a square root. Once again, when you expect it to look like a square root, that means that it is at least mildly tempting again to do some algebra, because these are equal. CA is 2 times of CM, and indeed I can call these ones x and x, y and 2y. I'll ignore the square root K for now. And if you were to want to do the question using, let's say, the cosine rule, that is enough. Again, you can use the cosine rule approach, which I will just acknowledge first. So small triangle and big triangle using the 60 degrees. Let's write it down. I can cancel off the 4. And then just subtract the two equations. This is not going to be a quadratic. It turns out to be fine. So subtract them or equate them, whichever you want to call it. Substitute it back, and you should get that your value of y is equal to 37. Y squared is 37. Wait, that looks wrong. Sorry, yeah, that is 4. This is to show you that I'm actually doing the calculations on the spot. It's not sorry, x is 6 and there's 28. Okay, now that looks right. Okay, and 2y squared is 112. So this is probably what I would do given this problem, since the cosine rule is pretty tempting with the 60-degree angle. Now, just like the other problem, if you want to avoid using trigonometry, it's kind of a little bit of like cop out, because to use the 60-degree angle in some other way is still using a 30, 60, 90 triangle in some form. So you have got two options, which I will let you see which one you prefer. I think the pretty natural way that you might want to do this is to drop a perpendicular. This is a 30, 60, 90 triangle. So this would be 2 root 3, and then you do some algebra again. Right, this is x plus 2, and then you will end up with cm is half of AC. So if you just call this y and 2y, again, you are going to end up with two equations, two unknowns, that does probably lead to the same outcome. Okay. So different x and y from just now, if you did this. If you divide this by 4 and then expand, in this case, you will solve and get y equals to 4, but then so x equals to 4, y squared is still 28, and so the same thing happens again. So this is the probably intended method for this question. Just again, two equations of Pythagoras. I feel like we've seen Pythagoras being used almost on every question. If you want to draw the perpendicular somewhere else, I think another place that you can try doing it is down here. You can also consider if you wanted to draw this, because then by your midpoint theorem, actually this is going to be parallel, and this is going to be isosceles, so some nice things also happen. Okay, but for round 1, this sort of equation-based approach tends to be good enough. Okay, so two different methods and one suggestion for question 22. Okay, question 23 is actually much easier than it looks. Or maybe you didn't even find that it looks very hard, you just didn't reach there, maybe. Otherwise, it's not so bad because of a very specific choice made, which is that it is from 1 to 9. Otherwise, things will get a bit more complicated if you have zeros around. 1 to 9 works well because you are working with divisible by 3. Right? So the question is basically a 7-digit number where every 3 in a row, well, I can say the number is divisible by 3 is the same as the digit sum divisible by 3. And you can think of it as I am just filling in 7 numbers one at a time. Each one is from 1 to 9. Now, we know that we can basically split up into buckets of mod 3. Our 1 to 9 are 3 equally sized buckets. These are all your 0, 1, and 2 mod 3 categories. For putting in the numbers, my thought is always, is there anything stopping me from just doing it one at a time from left to right / right to left? The answer is no, because I just have 9 choices for this. I have 9 choices for this. And after that, starting from the third digit, it's like, okay, I need to make sure that I pick the correct one mod 3. But whatever the requirement is mod 3, there's 3 choices. So no matter what goes in there, it is still going to be 3 choices and then all the way through. Right? There's no requirement about the entire number n to be like n must do this, n must do that. It's only blocks of 3 digits. So you just end up with a giant power of 3. Specifically, it's 3 to the power of 9. You don't actually need to write 3 to the 9, you just need to multiply them together. But if you happen to know some powers of 3, like 3 to the 6 is 729, then you can just start from there in your multiplication. Okay, 24. Now, I think 24 is the most difficult question in some sense for this paper. It is not that bad in terms of like the hardest questions of some years have been harder than this. But of course, as a problem, is it harder than the rest? Personally, I think so. So suppose the m and n are positive integers such that their product mn is a perfect square and m minus n is a prime number. I will want to always have the prime number get a name. And so I can write this as m equals to n plus p. I can write mn as n plus p. I want n times n plus p to be a perfect square, where p is prime. Now, I'm sure that you can think of many possible combinations of things that could give you a square. So there is also this bound here, which squeezes your m from 1089, which happens to be 33 squared. If you know, if you don't know, then is that useful or not, we will see. If you found it to be useful later, of course, you can always square root it yourself. And then we know that technically ending at 2026, they conspicuously picked this less than, which is such that it's actually less than or equal to 2025, which is also a square. Now, sometimes you can use the numbers in the question to derive some hints. And I think this would sort of suggest, maybe actually m and n, the n and n plus p here, are just forced to be square numbers. Like, number times a number is a square. Does it mean that it is a square? Does it mean that both of them are squares for it to be a square? Not necessarily in normal circumstances. I can have 2 times 8 is 16. It's certainly a square, and 2 and 8 are not squares. However, how it works is that for square numbers, you can think of it as all the prime numbers in your prime factorization must come in pairs. And so 2 times 8 is that 2 gave 1 2, 8 gave 3 2s, and so combined now you have 4 2s. N and n plus p, we can say that their GCD is going to be, this is like one step of the Euclidean algorithm, is going to be 1 or p. Now, when we say that it is 1 or p, that means that either they can share p or they share nothing. And everything else must come in pairs. Okay, so there are 2 cases therefore. Case 1 is that they share P, and I'm writing this very fast here because it basically disintegrates immediately when you subtract them. So it's like, is it possible that both of them are P times of a square? But if you subtract them, you realize that that is certainly not possible because it would require that your y squared minus x squared is 1. And certainly x is not 0, n is not 0. So this fails. Otherwise, then we get the main case, which is that they really are both squares. And that subtraction here gives you something else interesting, which is that the difference of squares is a prime number. That shouldn't happen normally because the difference of squares is factorizable. And so a tip for whether it be round 1 or round 2, right, is that every time when you do something and you're like, wait, that doesn't make sense, it either means one of two things. You wasted the last 1 hour or you're almost done with the question. Because when it doesn't make sense, it's either that really you were doing something wrong, like you bashed for 1 hour and it was wrong. Or more likely, it means that it doesn't make sense because it only works in very rare cases, which means that you have discovered why this has limited solutions and you're almost done. In this case here, it just simply means that y minus x is 1. Y plus x is p. Okay, so now I need to make sure that my m is in the correct range. And n plus p, remember, is your m. So I can just solve for y. It means that for the various choices of p, y is just p plus 1 over 2. And I now need the p plus 1 over 2 to sit between 33 and 45. Okay. And you can list out all of your primes. You are looking forward to the first prime, right? Not enough from senior. So there are 6 possibilities for p. We don't need to check back because we know that for each p, you're going to end up with a valid y, and x will just be 1 less than that. And we have already ensured that m falls into the range. We know that n is always going to be x squared, so no issue there. So this would just mean 6 solutions. Alright, so last one. You made it. We are at question 25, which is a very, very long-winded explanation again. It is starting off with a square, and then you draw another square, then you draw another square, then you draw another square, but you don't do this infinitely. You stop. The question could actually go on infinitely, and that would be a harder question, but it stopped. So good for us. Looking at the question's starting point, I know the size of the first square. If I don't, definitely I can't find any numerical values. I know the location of A prime is A prime is 1/4 of AB. Now, not 1:4. It is therefore that this is 1:3, not, don't mix up which one is 1:3, which is 1:4. Of course, more importantly, for the case of the outer one, it just means that 32 got divided into 4. You are left with, this is 8 and 24. All of them are, right? This is just by rotational symmetry. So the so-called outer shaded will just be 4 triangles, which you can compute. Okay, so that's sort of a pretty straightforward part if the question ended there. The question did not end there, so now you drew another one and then you drew another one. Well, there is this notion of similarity that doesn't just need to rely on similar triangles. You can have similar figures if one of them is clearly a scale version of the other one. And I can see that clearly if I were to take this inner square, this is just the same as the outer one in terms of the fact that you are shading these same 4 triangles. Right? So the same thing is just repeating. All I need to know is what is the new scale slash size. So to get there, I can go one step in first to let's say a prime b prime. A prime b prime by Pythagoras is 8 square root 10. Now that means that when you go one layer deeper, it will shrink by the ratio 8 root 10 over 32, which is root 10 over 4. So that's each layer, means that from ABCD to A prime, B prime, C prime, D prime. Now you're doing this again, which means that you're going to just multiply this same factor again, or rather you can just say you're squaring it, which would give you that this new size is 20. And so for the inside one, you can just repeat again that, oh, so if this is 20, then this 1 is to 4 would mean that's 15 and 5 for all of those respective things. And so the inner shaded parts would follow. Total area, sum them up. And we're done. In about 2 hours, it is just past 9. As I said about the SMO Junior, the good thing is that it doesn't require a lot of scary computation. It doesn't require you to have to do long workings for too many of the questions. Therefore, you didn't need to be as efficient as some of these solutions are. You could afford to brute force a bit more, you can afford to list a bit more, you can afford to do your calculations a bit more slowly, and it would still have been fine, right? So that probably would not have been the limiting factor. One of the biggest regrets for those of you who are new to SMO Junior is like, I panicked. The question looked hard, so I just skipped it. And I'm sure that applied to many of you on many of the problems. That's pretty normal. I would say that, of course, one remedy is that if you practice some more papers, then you will realize what sorts of things that they do to scare you that are actually not that hard. But another thing is just to realize that you don't need to know that your method is going to work when you start doing the question. You just need to do something that is mathematically correct, say things that are true and may be useful. Don't worry about only just saying things that you know are going to work. That's how school math works. That's not how Olympiad math works. And certainly that's not how algebraic manipulation always works. Sometimes you have to make the mess first and then you see what happens. Okay, so still, right, as some of you came a bit later and you asked, I don't have any strong evidence to change what I'm predicting for the cutoffs. I am not saying that these are definitely going to be correct. So if you're like, is it possible that if I got 12, I will still get a silver? Is it possible that I got 15, I can get it round 2? The answer is possible, is surely yes. Guaranteed is no. Right? That's all we can say at this point. And so therefore, if you are anywhere near to the round 2 cutoff that I am predicting, you should start to look at some round 2 questions, okay? Especially for junior. Junior round 2 is like infinitely less scary than senior and open round 2. But it is still much more sneaky, tricky, but also fun than the SMO junior round 1. Right? So I would encourage you to look at them. I have a few years, of course, on my channel, but also on AOPS, you can find all of the past year junior round 2s. Right? They're all there, so you can just try them as like sort of math snacks in a way of like, let me think about this for 15 minutes and then let me read the solution. Right? Get used to thinking about something for more than 5 minutes, which is how the round 1 time frame is like. And that will also help you for round 1 next time, be it junior or senior. Okay, I will sort of linger around for another 5 minutes or so just to answer anything from the chat that I haven't looked at. But otherwise, for anyone that is taking open tomorrow, all the best. If you're just taking it for fun, then just have fun. And look for maybe like 5 to 7 easy questions to try to do first. If you are really from junior, that's a good strategy. If you are sort of just here, but you're hoping to get into round 2, get into the national team, then of course, all the best. Yeah, so about the cutoffs, right? Just my prediction. If it turns out to be lower, then of course I'm happy for you. But I have to say that for junior wise, because of the fact that they're the largest number of participants, but somehow there are not more people getting into round 2, like not much more. So I don't really know what percentage or how many people get the silver, bronze, and honorable mention. I don't know if it's by percentage or by number. Like junior is about 4,000 plus participants, senior is more like 3,000 plus, but the number of round 2 qualifiers around the same, maybe differing by like about 10 or so. So I really don't know. And then open is about 2,000 each participants, but the number of qualifiers is still around the same. So round 2, that's the reason, right? There's a lot of people taking junior. Sometimes that's why the cutoffs can go up. But really, I don't know whether they give honorable mention silver, bronze by what makes sense or by like a specific guideline. Yeah, I am saying whatever cutoffs I mentioned is sort of like what I think is the like average likely cutoff, meaning that it is possible to be 1 mark higher, it's possible to be 1 mark lower. It is also possible to be, I don't think it'll be 2 marks higher than this for round 2 cutoff, like 18 feels too much, right? I mean, I think a round 2 cutoff of, when I say 16 means I think it is in the 15 to 17 region. But for the rest, is the error margin is kind of even bigger because I'm not too sure. I'm not too sure also because every year it's quite hard to establish what the cutoffs are because every time there are contradictory statements. Someone says they got 7 and got honorable mention, someone says they got 9 and they got nothing. So it's hard to even know what is the exact cutoff. Like even by the end of the SMO cycle. I wish you all the best nonetheless, of course. And I think that even if you have lower chances of getting into round two than you had hoped for, still look at it anyway, just maybe a bit less intensively because you want to get used to these kind of questions. By the time you hit senior, it's super scary. Last year's predictions, I think, were quite correct. I don't actually remember what I predicted apart from like the round two cutoff. I think it's around there. It's maybe plus minus one for most of them. Okay, I'll go off camera first, but I'll just leave the chat on for a few more minutes before shutting off. Okay.